Good morning to all. I'm Karthik, Assistant Professor, Mechanical Engineering Department from SNS College of Technology. As in previous videos, we have seen so many case studies, and this is yet another one case study. It's about wear failure in truck diesel engine tappets, right? So let's go. Uh, Everything as usual. Before starting about to see about this failures, this case study, we have to make some introductions about what we are going to analyze. The first thing is that there are three tappets are assembled in a truck diesel engine, were received for this failure analysis. In the other way, we can say that we are going to see what is the root cause for this failure. And the second thing is that we are with various degrees occurred at the end of the tappets, which is serviced only for 347 kilometers. As usual, we say we have some lesser kilometers services, but it is done only for 347 or 360 kilometers. Right. The next one is that these tappets are made up of chromium, moly, copper cast iron. Means the cast iron is with an alloy of chromium, moly, and copper, where this chromium and copper have good corrosion resistance, and the moly will have some high hardness and high strength. As this hardened phase of hardness of this hardened phase of this tappets is about 58 to 63 HRC. Means HRC means Rockwell hardness of C scale, right? So here actually the amount of carbon which is present in this type of tappets, it's rounds about 40%, 40%, but 40%, and that too we have some matrix of tempered martensite microstructure, which is obtained after quenching and tempering process. As usual, we can say after tempering process we have tempered martensite in many of the in many of the steel structures, right? In many of the steel structures. And comes to the next thing, we can say there are from visual examinations, we can see the three service tappets are and a new tappet for the comparison. In this, a very severe wear occurred in that end of the tappets one, and whose end can be had been burned out from a hole of 10 to 8 at the center, and oxidation colors present at the end. And the next one is that the end of the tappet 2 becomes more concave due to the intensive wear. Intensive wear means it is in other ways we can say this wear is particularly made on the other side, right? So here the axial wear thickness at the external edges rounds about from tappet 1 and 2 says it is respectively about 5 mm, 2 mm, while at the tappet 3 is 0.2 mm only. So here we can see due to that where you can see 8 mm inner thickness, and up to from 10 mm outer thickness you can see some holes are where things are happened in the engine tappets, and we can see there are different heights which is happened due to the running conditions, right? So in the next one, sorry sorry. Okay. When we take the same observations on this tappets, there are in previous picture you have seen four tappets, and the three are the we have heard one, or we are going to test out. And the other one is the new tappet. As in tappet one, you can see that is externally plug and the plastic flows are exhibited, and the second one you can see localized peel pits this happened due to bulk carbides. The third one is that the smooth and lot of strip-like carbides. The strip-like carbides is usually appeared when accidentally wear happens. And this is the microstructure. As see, this is the strip-like carbides and the other sim observations as we seen in the previous picture. Here, sorry, previous slide. Okay. The same observation thus says that the amount of carbon in tappet 1 and 2 is 10 to 15%, which is much less than specified percentage of 40. So when the carbon percentage decreases, we can see there will be decreases in the hardness and strength of the particular tappet. So in this structure we can see due to this vast decrease of that percentage of carbides, we can see less strength, so where it actually happens. In tappet 3 we can see it is 50 to 70 when compared to tappet 1 and 2, right? And see, this is the chemical composition, as all says it is more specified and it is more or less equal to the base structure, right? So here the hardness where we can see at the depth of 7 8 only, 7 8 the tappet has equal hardness, but when the depth of the hole is at first, second and third, so 1 m, 2 m and 3 m, we can see there will be changes in hardness stages, right? Sorry, hardness points, right? So as analysis, it is that according to the tensile technical specifications, that amount of carbide is less, and it is due to the it should be more than 40, but it is less there. And due to this, there is low hardness. So which when rubbing of the camshaft, high hardness camshaft is when it is rubbed with this tappets. Actually, where happens? The third one is that the amount of carbide, as we discussed previously, it is 10 to 15% only. So due to this there will be a poor wear resistance. As the other thing, the last thing which is more important, that there is insufficient cooling of the chilled phase. Means that as the wear happens, there will be temperature rise. So there will be in other ways we can say in other ways we can say that there is an insufficient, or we can say insufficient or non-uniform cooling. So the cooling rate is also different, and cooling is also different due to this wear test. So we can say that due to this type of wears, we can say the most failure case, the most important thing here is that the failure is due to the wear. So this wear is due to the low hardness because of the carbide percentage is well below the indicator level. So it is about 10 to 15%, but it is only it is 10 to 50%, but should be a 40% for the tappets. So that's it for today. As we have seen this case study about wear failures on truck diesel engine tappets. In forthcoming videos, we can see other case studies as well. Okay, thank you.